An object from another star system is racing through our solar system at 210,000 kilometers per hour. Using theoretical physics principles championed by Dr. Michio Kaku, we analyze what 3I Atlas really is. Could this be evidence of a Type 2 civilization? What does quantum mechanics tell us about interstellar travel? On October 29th, physics will give us answers. This analysis explores the Kardashev scale, von Neumann probes, and what the laws of physics reveal about visitors from other worlds. Imagine this. Right now, at this very moment, something is traveling through our solar system at 210,000 kilometers per hour. It came from another star system. It's been journeying through the void of space for possibly billions of years. And here's what makes physicists like Dr. Michio Kaku pay attention. The laws of physics, the very fabric of space-time itself, can tell us whether this is a natural object or something far more extraordinary. I'm talking about 3I Atlas, and what I'm about to share with you will change how you think about our place in the universe. Dr. Michio Kaku has spent his career explaining how advanced civilizations could traverse the cosmos. He's described the Kardashev scale, the physics of wormholes, the possibility of interdimensional travel. And now, we have a real interstellar object passing through our cosmic neighborhood. The question isn't just what it is. The question is, what does physics tell us it could be? In the next 10 minutes, we're going to examine 3I Atlas through the lens of theoretical physics. And I promise you, by the end of this video, you'll see this object in a completely different light. Let me start with the discovery. July 1st, 2025. The Atlas telescope system in Chile detected an anomaly, an object moving at velocities that shouldn't exist for anything gravitationally bound to our sun. When astronomers calculated its trajectory, they realized something profound. This object has a hyperbolic orbit. In physics terms, that means it's not trapped by our sun's gravity well. It came from interstellar space, and it will return to interstellar space. This is a traveler, not a resident. Now, Dr. Kaku often talks about how Type 2 civilizations that can harness the energy of their entire star system, would need to send probes across the galaxy to explore. He references something called von Neumann probes. These are self-replicating machines that could traverse interstellar distances. And here's the critical part. They would look for star systems with planets, especially planets with liquid water and the potential for life. Sound familiar? That's exactly where 3I Atlas is heading, into the inner solar system, past Earth, past Mars, toward the Sun. But let's apply physics rigorously. NASA's Hubble Space Telescope captured detailed images. What they saw was a teardrop-shaped coma, a cloud of gas and dust surrounding a solid nucleus. The James Webb Space Telescope analyzed its spectroscopy. High concentrations of carbon dioxide, water vapor being released at tons per second, carbon monoxide, cyanide compounds, organic molecules. From a purely chemical standpoint, this matches what we'd expect from a comet. But, and this is where it gets fascinating, there are anomalies that make physicists pause. First anomaly, activity profile. Normal comets in our solar system become active when solar radiation heats their surface, typically around Mars' orbit or closer. The sun's energy sublimates the ice, turns it from solid directly to gas, creating the characteristic tail. 3I Atlas became active far beyond Jupiter, way out in the cold outer solar system, where solar radiation is weak. Why? What energy source is driving this premature outgassing? Standard thermodynamics doesn't easily explain it. Dr. Kaku would ask, what are the possibilities? 1. It formed in a different stellar environment, where volatile ices sublime at much lower temperatures, perhaps around a cooler star, where carbon dioxide ice is more prevalent than water ice. 2. Internal radioactive decay is providing heat from within. 3. And this is speculative, tidal forces from its journey through interstellar space created internal friction that's now releasing stored energy. Or 4. Something we haven't considered yet. Second anomaly: velocity and trajectory. This object is moving at approximately 61 kilometers per second relative to the Sun. That's fast even by interstellar standards. When we trace its path backward through the galaxy, modeling its trajectory through the gravitational fields of nearby stars, we find something intriguing. It likely originated from the thick disk of our galaxy, a region filled with very old stars, stars that formed 7 to 10 billion years ago. That means 3I Atlas could be older than our entire solar system. Think about that. This object began its journey before Earth existed, before our Sun ignited, traveling through the darkness of space for eons. Now, here's where Professor Avi Loeb from Harvard enters the conversation. Loeb, like Kaku, pushes the boundaries of conventional thinking in astrophysics. He asks the question that many scientists avoid. What if some of these interstellar objects aren't natural? What if they're artificial? He points to Oumuamua, the first confirmed interstellar visitor, which had a highly unusual elongated shape and appeared to accelerate slightly as it left our solar system. Non-gravitational acceleration. That's physics language for something as pushing it besides gravity. Loeb suggests we should consider the possibility that advanced civilizations send probes throughout the galaxy. Not huge starships with aliens aboard, but small automated craft. Von Neumann probes. Self-replicating robots that could explore millions of star systems over millions of years. The physics of this is actually sound. A civilization doesn't need faster-than-light travel to explore the galaxy. They just need patience and self-replicating technology. Launch a probe, it travels for thousands of years into another star system, uses local resources to build copies of itself, and those copies spread further. Exponential exploration. Now, Loeb makes a testable prediction about 3I Atlas. He says, watch what happens on October 29th when it reaches Perihelion, its closest approach to the Sun. If this is a natural comet made of ice and rock, the intense heat and gravitational stress should cause it to fragment, to break apart. Comets are fragile. We've watched them disintegrate before. But if 3I Atlas remains intact, if it passes through perihelion without fragmenting, that tells us something about its structural integrity. It suggests the object might be made of something more robust than ice and dust. Let me be clear about the physics here. The tidal forces near the Sun are immense. Any object held together only by weak gravitational self-attraction or the structural strength of ice will be torn apart. It's called the Roche limit. If you get too close to a massive body, tidal forces overcome the forces holding you together. Natural comets often fragment. We've seen it happen. So, if 3I Atlas survives intact, Physicists will need to explain what's holding it together. The majority of the scientific community, and I want to emphasize this, believes 3I Atlas is natural, a comet from another star system. Rare, yes. Exciting, absolutely. But natural. And that's the most likely scenario based on current evidence. However, what makes science beautiful is that we test our assumptions. We observe, we measure. We let nature reveal her secrets. That's what's happening right now, with every telescope on Earth and in space pointed at this object. Let's talk about what we're learning from a pure astrophysics standpoint. The chemical composition of 3I Atlas is giving us unprecedented data about planetary formation around other stars. You see, our solar system formed from a specific mixture of elements in a specific stellar nursery 4.6 billion years ago. But every star system is slightly different. Different ratios of carbon to oxygen, different amounts of heavy elements, different temperatures and pressures during formation. The fact that 3I Atlas is rich in carbon dioxide, more so than typical solar system comets, tells us about its birthplace. It likely formed in a region where carbon compounds were more abundant, perhaps around a star slightly more carbon-rich than our Sun. The organic molecules detected, tholins and other carbon chains, suggest complex chemistry happened in that distant stellar nursery. We're literally studying the chemistry of another world. That alone is extraordinary science. Dr. Kaku often discusses how physics predicts multiple pathways for life and intelligence to emerge in the universe. The same laws of chemistry that created life on Earth operate everywhere. The same quantum mechanics, the same thermodynamics. If complex organic molecules form readily in other star systems, and 3I Atlas proves they do, then the chemical precursors for life are scattered throughout the galaxy. That's a profound realization. Now, let's address the elephant in the room. The possibility, however remote, that this could be artificial. What would we look for? Dr. Kaku has outlined this. First, non-random geometry. Natural objects are irregular, chaotic. Artificial objects often have symmetry, right angles, specific ratios. Second, non-gravitational acceleration or deceleration. If something is changing velocity without an obvious gravitational cause, that's interesting. Third, electromagnetic emissions. Radio signals, infrared signatures that don't match thermal radiation. Fourth, trajectory adjustments. If an object subtly changes course, that implies propulsion. So far, none of these signatures have been detected with 3I Atlas. It appears to follow a purely ballistic trajectory, determined by gravity and its initial velocity. No radio emissions, no course corrections. The shape appears irregular based on how its brightness varies. It looks, for all purposes, like a natural comet. But, and here's the scientific approach, we keep observing. We don't assume, we measure. October 29th is critical. Multiple spacecraft are positioned to observe. The European Space Agency's JUICE mission will capture detailed imagery. NASA's Hubble will monitor any fragmentation. The James Webb Space Telescope will analyze the gases released as the comet heats up. Ground telescopes across Earth will track its position and brightness. This is one of the most coordinated observation campaigns in astronomical history. And for good reason. This is a piece of another world passing through our neighborhood. We'll never get this chance again. After October 29th, if the comet survives intact, Scientists will calculate its structural strength. If it fragments as expected, we'll study the pieces and learn about its internal composition. Either outcome gives us data. Either outcome teaches us something about how objects form around other stars. That's the beauty of science. Even a null result is a result. Let's think bigger for a moment. Dr. Kaku frequently discusses the Fermi paradox. If the universe is so vast, if there are billions of potentially habitable planets, where is everybody? Why haven't we detected obvious signs of advanced civilizations? One answer he proposes is that we're not looking correctly. We're searching for radio signals, for obvious megastructures, for things we understand. But a truly advanced civilization, a Type 2 or Type 3 on the Kardashev scale, might operate in ways we can't comprehend yet. They might communicate through quantum entanglement, leaving no electromagnetic trace. They might exist primarily in virtual realities, having no need to physically expand across space. Or, and this is relevant to 3I Atlas, they might explore the galaxy through subtle means. Small probes, objects that look almost natural, camouflaged in the noise of cosmic debris. If you were a Type 2 civilization sending millions of probes across the galaxy, would you make them obvious? Or would you make them blend in? I'm not saying 3I Atlas is artificial. The evidence strongly suggests it's natural. But the question itself is scientifically valid. It's worth investigating. Because if we ever do encounter something artificial, we want to recognize it. We want to understand the signatures. Every interstellar object we study teaches us what natural looks like, which helps us identify what might be unnatural. Here's what we know with certainty. 3I Atlas originated outside our solar system. It's approximately 5 billion years old, give or take. It contains water ice, carbon dioxide, carbon monoxide, and organic compounds. It's currently traveling at 61 kilometers per second. It will reach perihelion on October 29th at a distance of 1.4 astronomical units from the Sun, between Earth and Mars. It poses no threat to our planet. And after swinging past the Sun, it will head back into interstellar space, never to return. From a physics perspective, we're witnessing something profound. The laws of thermodynamics, the principles of orbital mechanics, the chemistry of molecular bonds, all of it plays out in real time with this object. We can calculate exactly where it will be at any given moment, using Newton's laws and Einstein's corrections for relativistic effects near the Sun. Physics works. The universe follows rules, and those rules allow us to understand objects from unimaginably distant places. Dr. Kaku reminds us that we live in a golden age of discovery. We have the technology to detect interstellar visitors. We have space telescopes that can analyze their composition. We can apply theoretical physics to understand their origins and predict their behavior. 50 years ago, we couldn't do any of this. 50 years from now, we'll likely have even more powerful tools. But right now, today, we're the generation witnessing these cosmic travelers. So what's my conclusion? Based on the physics, based on the spectroscopy, based on the trajectory and behavior, 3I Atlas is almost certainly a natural comet. A magnificent, ancient interstellar comet carrying the chemical signature of another stellar nursery. It's a messenger from a distant world, billions of years old, giving us a glimpse into how planetary systems form elsewhere in the galaxy. That, to me, is just as exciting as if it were artificial, because it tells us the universe is connected. The same processes that created our world created countless others. But science demands we remain open to evidence. If something unexpected happens on October 29th, if the comet behaves in ways that violate our models, then we adjust our understanding. That's how science progresses. Not through dogma, but through observation and willingness to be surprised. In 8 days, telescopes worldwide will watch as 3I Atlas makes its closest pass by our sun. Whatever we learn adds to humanity's understanding of the cosmos, and that's what makes this moment extraordinary. We're not just passive observers. We're actively studying the universe, applying physics and chemistry, asking bold questions, and seeking evidence-based answers. What do you think? Could 3I Atlas be something more than a comet? Or is the natural explanation sufficient? Share your thoughts in the comments, and subscribe to this channel, because on October 30th, I'll break down the observation results. We'll analyze what happened at Perihelion together. This is physics in action. This is discovery in real time, and I want you to be part of it. The universe is revealing its secrets, one interstellar visitor at a time. Let's explore it together.